right. Hello, everybody. Welcome to another CSAT LSAT Action Team webinar series. We're going to give everybody a few minutes here as we kind of trickle in. We've got folks coming all around the world, so I think we've got just about every time zone on the planet covered in this webinar today. So we're pretty excited. For those that are not aware, this is the CSAT and LSAT, so Cold Spray Action Team, Large Scale Additive Action Team webinar series for some of our key sponsors and supporters of the Action Team series who are really helping to make sure that this community and this group stays at the forefront of technology development and innovation. And so if you're not aware, each year the CSAT and LSAT event are held. This year it's going to be June 11 and 12 for CSAT and June 13th for LSAT. It will be at the DCU Center in Worcester, Massachusetts. And so you'll be able to stop in and see Titomic, who's our presenter for today, dear friends and sponsors as well as a lot of the other participants, supporters, sponsors, other folks that you'll see on the webinar series, and some amazing talks. So the agendas are just about finalized. We've got some really, really rock solid keynote speakers from NAVSEA for LSAT. We've got a whole bunch of folks from just about every different industry under the sun for CSAT. And so we're going to be able to see a lot of different perspectives on where cold spray is going, as well as where large additive is going. And so it's really cool when we get to actually merge those two together. And so that's the conversation that we're going to have today. And so our friends over at Titomic are going to talk to us not just about cold spray, not just about large scale additive, but about the intersection of the two and what it means to different industries, to different groups. So we're going to go through a bit of a presentation here, and then we're going to have some time for a bit of Q&A and conversation around this as well. So we've got some pre-submitted questions that we're going to talk through, but we're also going to take live questions as well. And so if you want to save those questions, you can post them in the chat and we'll get to them at the end. And we'll have a really good conversation around kind of the future of cold spray, coatings, repair, additive manufacturing, and everything that the team over at Titomic has been up to all around the world. And so with that, I want to turn it over to our team over at Titomic and let you guys kind of jump in here with us.
Thanks very much, Aaron.
We might have frozen slides, Nicole, if we want to slide to the next couple here. Perfect. So Dominic, we'll turn it over to you guys to kind of give us a good sense of who you are, where you're coming from, and what the Titomic team is really all about.
Thanks very much, Aaron. I'll give you a brief introduction to the three of us who will be presenting today who are on the team. Neil has been, I like to call him the grandfather or godfather of cold spray in Australia, and he has substantial experience, and I'm sure many of you at CSAT know him exceptionally well. And he has brought a wealth of experience to the Titomic team with his aerospace background as well as his strong cold spray background. He's based here in Melbourne, Australia, and is our senior technical fellow responsible for assisting us in guiding our activities technically. I'm Dominic Parsonson. I'm head of sales and marketing for Titomic based in Melbourne, and I support the team globally around where we go with cold spray, what it means to us, and how we add value to our customers. And then last but not least, Bruce Coulter, who's our general manager and president of Titomic USA, who has a wealth of experience in the additive manufacturing sector and works strongly to support our team and our customers in the USA or the Americas, North and South, to ensure that we can provide added value solutions. Next slide. So who is Titomic? Some of you may have known us for a number of years, and when we first started back in 2014, all the way through to 2018, when we listed, Titomic was strongly focused on bicycle frames, golf clubs, and a few more consumer-oriented products. And during our development phase from about 2018 to 2020, we strongly started focusing on where does cold spray really add value? And we narrowed down the focus of what our business means and what it is we actually do to be able to give a very clear message to our customers where the value is Titomic provides. So we now refer to ourselves as a manufacturer and integrator of cold spray systems. What that means is we develop and produce our own cold spray systems in the low and medium pressure systems. And in the higher pressure systems, we integrate technology from around the world that best suits our customers' applications. So in that area, we're largely technology agnostic. And what we do is we look for a solution, whether it be ours or someone else's, that provides the best added value to our customer. And we integrate that as a solution. And integration is far more than just the building of a machine. It comes down to recipes, parameters, specifications, processes, heat treatment recipes, HIT recipes, to ensure that we can give our customers a complete package of solutions. We're also an additive manufacturer of components, as not every customer wants to own his own cold spray system. So we also develop cold spray systems that are customized for specific AM applications. And in many instances, we actually take on the manufacturing of those AM parts for our customers until they are ready to invest in the machinery themselves, or potentially we will continue to do it into the foreseeable future. And then we tackle coding and repair, where we act as a service provider as well as a solution provider into that industry. We have a broad range of experience. 2.5 years ago, we acquired a company out of the Netherlands who've been doing cold spray for over 15 years. And then when you look at the people within Titomic, we now have, including Neil's 100 years of cold spray expertise, we now have over 200 years of real cold spray expertise. So we are there to act as a partner for our customers to provide a genuine solution to ensure that we progress cold spray. That's what Titomic's about. We focus solely on cold spray and nothing else. Next slide. So if you look at our low and medium pressure and high pressure activities in cold spray, we recognize the value that cold spray can add across a broad range of industries, but we try to narrow it down where we can add the best value, and we leverage the things that make cold spray unique. High-speed manufacturing, low heat-affected zones, ability to blend metals that typically don't belong together, and the ease of use in many applications. So in low pressure, we focus very strongly on remanufacturing sector. So we're talking about diesel engines, large engines, shafts, where we are assisting keeping infrastructure on the go longer and restoring it to its original condition. And their cold spray, as most of you will know, has some unique capabilities with regards to speed and low heat. We also do a lot of work in the maintenance repair sector. There we work with our oil and gas works, but to develop procedures and processes. So we have worked for the last 6 months with a large oil and gas company in Australia, looking at not just as a technology work, but how do we certify it? How do we validate it that it works over and over again, and working on repeatability? And this is where Titomic works with its team globally to ensure that we don't just provide you with a machine that sprays metal, but we provide you with the complete solution. Next slide. In the high pressure area, we focus on a number of what we call pillars, but in principle, we are focusing on manufacturing. How can we take Inconel, titanium, stainless steel, and a variety of these metals and turn them into genuine end-use parts? We view cold spray as an effective replacement for casting and forging applications, and there we are looking at how do we do it quickly, how do we do it repeatably, and how do we ensure that the mechanical performance you get out of the metal we spray meets or exceeds what the customer expects for his application. And that's the key focus area for us, always ensuring that not only are we depositing a metal, but that we are depositing a metal that genuinely performs the way you'd expect it to perform. We don't believe it's good enough to be able to put material in a powder feeder, spray it, and say, look, we have sprayed metal. We believe in validating with clear data and performance specifications that this material behaves the way you would expect it to behave. And that's often work done from an R&D perspective within Titomic, or work done collaboratively with a customer or a research institute. We put a lot of effort into functional coatings, and functional coatings are coatings where we are, where the coating is more than just geometry restoration or corrosion, where we are adding the capability around thermal barriers or electrical performance. And this is an area we see enormous growth in both aerospace as well as electrical and terrestrial applications. Next slide. So Titomic is global. We have head office in Melbourne, we have manufacturing and research center in Europe, as well as in Australia, and we have a small technical center in the USA, growing very, very rapidly. And in fact, I wouldn't be surprised if you see the USA starting to overtake the world in the next 18 months or so, if not quicker. We have a broad reseller network around the world, ensuring that we can provide service, support, and technology to our customers as they need. Next slide, please. Briefly, broad range of machines. So in our low and medium pressure space, we go from our D523, which is a portable or mobile low pressure spray system, typically used in the ductile metals like aluminum or aluminium, depending which country you come from, zinc, nickel, and a few others. It's easily deployable, and in fact, you might have seen that we recently sold 10 of these to the Dutch Army to use as forward deployable systems. D623 is a brand new machine, still sitting in early beta stage, but that's a medium pressure system that allows us to push the boundaries between low and high pressure with regards to the nature of the metals we spray, the speed with which we can spray them, and the mechanical performance. And our ISB series is where we take those D523s or 623s and we combine them into a single solution that includes robotics, extraction. So it becomes very easy for a manufacturer or education institution to take an ISB and plug and play it. Next slide, please. And then we focus on our high pressure systems. And there we have our TCAF Custom, which is where we build very large scale additive manufacturing solutions or coating solutions specifically for customers' needs. Our TCAF 1000 is the one that people may have heard about the most. That was our first machine, commercial machine was installed 2 years ago at TWI in the UK. And that is a highly functional additive manufacturing solution that can do parts 1 meter by 1 meter by 1 meter, utilizing nickel, titanium, Inconel, and a variety of other expected materials. And then we recently launched our TCAF 3250R, which we commissioned in January in Australia, and that is our newest solution. So it's optimized for rotational and spherical builds, can do parts up to 3.2 meters in length and almost 2 meters in outside diameter, depending on the weight of the part. It's got an advanced and new control system, and it's something we're incredibly proud of. In fact, we have a photo of some of the Solvus team visiting us, where we were proudly demonstrating this machine to them. That has now been running for 5 months and is proving to be a phenomenal addition to our portfolio. Next slide. So that's enough about our machines and what it is we do. Now I'd like to focus on some real-world applications. I'll be talking about the additive manufacturing opportunities and applications we've worked on. Neil will cover the coating and repair. So in additive manufacturing, we break our business into armaments, ballistic protection, structures, and tooling. And the reason we've done that is so it becomes easier to explain to the market what it is we're doing and become easier to advocate for the technology. Those capabilities go into a broad range of areas: transport, automation, mining and resources, defense and aerospace. But typically we favor anything that is rotational, cylindrical, spherical, or large flat surfaces that have a slight two-dimensional curve to it. And that's where tooling starts to add value. But the benefit of cold spray in all of these applications comes down to the well-known characteristics of high-speed deposition, excellent mechanical performance of the material, high density, and the ability to replace casting and forging with a near net shape as rapidly as possible. So for those of you who may not be familiar with cold spray, we always highlight here that cold spray is not a competitor to traditional manufacturing. It is not a competitor to powder bed fusion or E-beam or any of those technologies. It's an added tool in the toolbox for a manufacturer to provide solutions to the marketplace. So we can't do those tiny, highly specialized parts you would typically see from a powder bed fusion type additive manufacturing space, but where we really add value is size, speed, and near net shape. Next slide. And one more. So I've got a few applications I want to show you that are real-world applications. This is a very large rotational part that was produced in commercially pure titanium. And a number of you may throw your hands up and say, why commercially pure titanium? And I think I'll mention it now. Yes, we do a lot of work in Ti 6.4. But commercially pure titanium offers a real sweet spot for our end users in cost of the raw material, speed of manufacture, and our ability to tailor the mechanical behavior of the commercially pure titanium. So depending on which recipe we use in our system, and we call them recipes, as those are naturally, temperature, pressure, speed across the surface, standoff distance, etc., as well as heat treatment and HIP recipes if required, we can tailor the mechanical behavior of the commercially pure tie. So with the right recipe, we can get it to behave almost within 5% of about Ti 6.4. And with some of the new developments, I wouldn't be surprised to see it match Ti 6.4. But the powder comes at least at a third of the price of typical Ti 6.4 additive manufacturing powders, which then starts to add the benefit to the customer of saying, are you using Ti 6.4 because you've always used Ti 6.4? Or are you using Ti 6.4 because you need it? Or could we look at an alternate, like commercially pure titanium, where you have price, speed, and technical opportunities? But again, to highlight, we offer both. So in this particular application, the customer was making this large deployment ring for a satellite application, and he was machining it out, intending to machine it out of an aluminum billet or an aluminium billet. But the wastage was high, time on the machining center was exceptionally long, and he was looking at a way to do it faster and cheaper. So we produced that titanium, commercially pure titanium ring, 1.2 meters in diameter, produced at about 60 kilograms in under 10 hours, vertical walls, holes, everything all in one go. So that part has not been machined, not been heat treated. That came off our system looking exactly like that. And there, the benefit to the customer was weight reduction, cost reduction, an improvement in his sustainability profile in the sense that he was no longer wasting such a large quantity of materials. And slides seem to have changed. Great, thanks, Nick. So we are also putting a lot of focus on pressure vessels. The cold spray process has this amazing benefit of being able to produce single piece pressure vessels where required. So when you look at those two pictures on the slide, both of those were produced in one go. No joints, no welds, no post-fabrication other than surface machining. So we can include standing bases, equatorial flanges, the neck, the base, all done in a single go. That's an 8-liter pressure vessel produced in cold spray in just under 1 hour. And then if you include a heat treatment batch and a light machine on the exterior surface, we are talking about go to woe of a few hours to get a finished pressure vessel, which offers some enormous benefits. Most of this work has been done on our TCAF 3250, which is the one that we have commissioned now in January. And the benefit there is it's really fast, exceptionally well controlled, and designed to produce things like pressure vessels, barrels, flanges, shafts, barrels, and other freeform components. So this is the latest and the newest that we are working on and has been going exceptionally well. Next slide. This application is a great example of near-net shape replacement. So many of our customers come to us with a machining solution, a machining challenge. This particular customer is Yongya out of the Netherlands, who manufacture large ball valves for the food industry and other industries. But the challenge they had with this particular ball valve was it was being produced out of Hastelloy as a single billet and machined. And the time on the machining center was so long that for them to increase capacity or increase production rate would have been an investment in further machining centers, which was not viable for the size of the project. So they approached us to see if we could produce it in Inconel or Hastelloy. And we looked at it and we thought that it would actually be well suited to commercially pure titanium. The strength matched. The titanium offered some weight and corrosion benefits. And the trial was around producing a near-net shape that would reduce their machining time, therefore increase their ability to produce a larger volume of parts per year. So that was done as a near-net shape rotational spray on our TCAF 1000, done on a substrate. So the interior of the ball valve is almost to final tolerance. It needs a light skim machine to get it to final tolerance and smoothness. The external is designed so that the finished part nests within that near-net shape. And when you look at those photos, you can see at the top image on the right-hand side, that is how it looked as a neonet shape, top and the bottom. The center is us spraying it, and we start off with what looks like a cylindrical ball. And then you can see that last image is a fully completed flange ball valve. In that form, it saved the customer time, increased his productive capability, gave him a lighter, stronger part with improved corrosion resistance with no negative on pricing in his marketplace. An exceptional application. This is now also going through certification, and I believe that the Lloyd's, or whatever they're called now, have now certified this as suitable for use, which it would be our first non-aerospace certified component. In fact, if everything is going right, we have a video of this production on the next slide. And just to highlight, we've had some challenges with our videos. If it doesn't work, we will send it out separately as a URL. Nicole, are we going to try and do it via the link, or? Brilliant. So as you can see, what we start off here with is an initial substrate, which or form, which becomes the inner of the component. We then measure it up, ensure that it's running parallel, that the dimensions are right, and then we spray the commercially pure tie. And as this sprays, you can see how we manage the spray differently in different areas to start building that neonet shape. We are able to stop, go in and measure if required. So the beauty of titanium cold spray and a number of applications is it is possible to stop and start with no negative impact on adhesion or mechanical performance. So if we had wanted to, we could stop this spray, ensure there's no nitrogen in the cell, go in, double check that everything is going to tolerance, that there's no unexpected behavior, and continue spraying. So one of the packages of work we've been doing over the last 3 years is actually ensuring that stop and start sprays have no negative impact on mechanical behavior, adhesion, or any other tolerance challenges. So I believe that is now it for me. And next slide should be handing over to Neil to talk us through our coating and repair applications. Thank you very much.
Thanks, everybody. Dom has done a wonderful job of introducing the concept of the equipment and the technologies, and made it quite clear the importance that we place on providing solutions. Are we able to go back one slide? I'm just looking at the presentation you currently have. Okay, keep proceeding. Thanks. So effectively, what we've seen within Titomic, particularly over the last 2 to 3 years, a significant growth in our repair and coating capability. And that growth is both as a service provider through equipment and solutions, and for a number of other elements. This is a particular element we have, which is a high pressure repair capability for our Melbourne trams. We are a little bit unique in the world that we still run trams. There are trams operating in other cities around the world, but it is a prime transport mover within the Melbourne. And they were having significant troubles in maintaining these large systems in service. So what we were able to do is we're able to develop a deposition procedure using nickel to replace the existing shaft coatings, and more importantly, focus the deposition in the areas of repair without disassembly. The significance of this in terms of an application and a solution to the customer is we went through a significant amount of testing and validation. We often hear is that is a technology for geometry. In part it is, but I think we all understand that cold spray and cold spray depositions do carry load. And in this application, we went through a number of validation processes and testing, and were able to work with the customer to come up with an acceptance criteria. So that now has been accepted, and it's an ongoing product. that we provide the customer. As I say, tailored for high pressure, and it's a service we currently provide. Next slide, please. We operate now in many industries, significant industries, and we've been in space. We've mentioned the transport industry, the rail industry. We're very active in the mining industry. We're very active in the gas and fuel environment, and we are also very, very active in defence. And that again comes through either the application of high pressure, medium pressure, and low pressure. And again, this is one of the elements that we've actually been able to put product into space, and that's been successfully tested. Again, it was produced with our 1000 series system, and it was able to provide a lightweight solution in comparison with many of the other existing production processes. We did a lot of this work, and we continue to do a huge amount of work with our research partners, and that can be a research partner, a defence research partner, universities, and other agencies that we have to assist us in the validation, in the testing, in some of the predictive modelling we do, and all those sorts of things. So it's very, very gratifying to see that we can actually develop these solutions, and this goes through a validation test program, which we agree with the customer. And that's their way of certifying and accepting. Next slide, please. We'll try another video. Handheld is a very, very significant part of our repair strategy, in which we are delivering technology to the target or technology to the customer. And this is a very, very active program that we have all around the globe. And it really is significant, where we have large pieces of equipment which are very, very difficult to disassemble, time consuming, and this is particularly relevant in areas such as the mining industry and the gas and fuel programs. This is a simple illustration of a repair of an engine component, and you can see how quickly it is. I think anybody that's familiar with the coal spray have seen many of these photographs and images. And we have a number of elements in trial at the moment with our Defence Department in their land vehicle. We're working very, very closely with the gas and fuel, particularly in the element of corrosion protection and repair for large fuel compounds, particularly those that are in the marine environments. But again, I think what it demonstrates is that it's a very, very quick and very, very easy process to apply, and produces outstanding results. Next slide, please. Okay, so we're also looking at advanced projects. So we've already discussed the concept of an integrated system, but also we're now looking at integrating other elements such as toolpath, basically some of the visualization programs, predictability models. And I've picked this one out. This was conducted by our colleagues in the Netherlands, to basically show how we can actually produce a solution that does introduce many of these elements of additional activities. Next slide, please. So what you'll see here is, and this is in the glass molding industry, and it should be able to be seen that we can actually translate this to other mold industries. But this industry has basically a very, very manual process for working hot molds. So these molds are obviously those that were injected with molten glass, and the way they sustain those at the moment is basically applying swabbing manually. And what we're really trying to do is to come up with a solution that we can basically keep reutilizing worn molds and eliminate this manual process. significant in reducing time, but effectively there's a high cost and downtime associated with this process. Next slide, please. Excuse me. So what we've done is, and this has taken quite a long time, and it does come through our company in the Netherlands, but basically it was to look at another way of basically reutilisation of moles in a timely function, and basically to be able to select moles, be able to scan them so that we can determine where the faults are, where the wear is, spray, do a cold spray to create a hard wearing surface, and then do a performance check and a quality check to make sure that the mold was correctly aligned and the geometry was restored. We do have a video on the next slide to give you an indication of how you can integrate a number of existing technologies with cold spray. So what you've got there is that the mold's been selected, its profile's being measured. We then create a software program to recover the profile using cold spray, and you'll see that there. And then obviously a machining process, and then it goes back into service. So this is basically an automated process of taking it off the line, repairing the mold, and putting it back into the line. Thank you. Next slide. So what I wanted to touch on very briefly here is that we are conscious of the digital world, and we are very, very focused on how we can implement a number of the current digital parameters through our association with research organisations, and effectively using real data. We do have, particularly on some of our high pressure systems, the ability to record a number of output parameters. So whilst we're very, very conscious of the significance of monitoring input parameters, we're also very, very conscious of the need going forward is to manage output parameters and to utilize those output parameters in a machine learning process. If we go to the next slide, I just want to touch on a couple of these at the moment. So we look at some of our digital twin or virtual twin technology. The fact of the utilization of digital capability in a range of products is now enabling us to use some of the predictive models that have been developed, particularly for the likes of density and porosity and even mechanical properties, and use the output parameters that we're generating in the machines as part of a machine learning process. So what we can then is we can start to develop very, very realistic predictive models based on the machine learning, and we've already done that on a number of areas, as I say, with density, porosity, and we're now looking at the ability to use the machine learning and the predicted capability and the data we're collecting to look at some of the mechanical properties. This work is being done in collaboration with the universities, and we're starting to release a number of papers on the outcomes of these. The other two I want to briefly touch on is augmented reality, which will mean that we'll be able to incorporate this digital technology, particularly on large applications or in large area applications where you lose the visibility of the repair. Now, we claim and we successfully are able to restore geometry as both a repair and alternate coatings. In many, many cases, these applications are subsequently painted or primed and painted. So the real challenge there is particularly for large scale production facilities and even large-scale equipment like marine vessels and things like that, is to be able to monitor in-service performance of repairs. Most users require that to be done. So the augmented reality enables us to basically clearly identify where the repair was and to be able to continue to track that while it's in service. The other one is tool path planning. That's very, very important to us, particularly in repairs of complex shapes and things like that, to enable us to basically ensure that we match the geometry. Next slide, please. Yeah, so that's me for now, and I guess we'll throw open to questions or discussions. Thank you very much.
Awesome. Thank you, Dom. Thank you, Neil. This was fabulous to see just a little bit of what you guys are up to. And I know that, you know, there's so much experience that your team brings to the table across the world. And so I think maybe just to start, it would be great to get a sense from you guys where you see kind of the future of cold spray going with all the experience that the Titomic team brings to the table, and you know, we really appreciate you guys being supportive of this ecosystem and you guys kind of being pillars of the community. Where do you see it going in the next 3, 5, and maybe 10 years down the road?
I'm not sure which one of us will answer the right answer, so I'll start and then Neil can jump in and correct me when I'm wrong. But I'll talk from personal experience. So I've been in cold spray only 5 years, and when I started 5 years ago, when you spoke to industry and went out to industry and said we do cold spray AM or we do cold spray coating and repairs, there was not so much knowledge about what cold spray was, firstly, what benefits it brought with regards speed, performance, heat, etc. But what we're seeing now is with the concerted efforts of all of us, CSAT, LSAT, every other competitor or company in the cold spray space, is that now when we go out and talk to industry about cold spray and what it can do, there is a sense that people have heard about it. They understand it. If you look, there are more papers being written about it. If you look, the fact that we are working together with the cold spray community to develop an SAE specification for cold spray for additive manufacturing. All of those mean to me that cold spray is starting to come of age. You know, when you look at technology adoption, the famous one is the technology adoption life cycle, which talks about crossing the chasm. You know, you have all of your early adopters, which are us, who've said this technology is exciting, and then it takes a while for industry to really pick it up. And I think we've done this now. I think we've actually starting to cross the chasm. We are seeing inquiries come in from people who 3 years ago wouldn't have known what cold spray was and wouldn't have known who Titomic is. And now they're coming in very clearly saying, we have looked at it, we've read about it, we've researched it, we've seen what you've done. Please talk to us about buying a machine or building a solution. So I think we're very close to completing crossing that chasm. I think there's an increase in acceptance and demand from the market. And I believe in the next 5 to 10 years, cold spray will not be a niche novel application in AM and coating repairs. It will be taught in colleges and universities. People will come out of technical training with welding, thermal spray, and cold spray as a capability, and it will be a known and accepted tool in a manufacturing toolbox. It may be my sales guys' rose-tinted glasses, but I definitely have the firm belief that 5 years from now, we will not be having the conversations about what cold spray is, but more about what it's doing. Neil?
Thanks, Dom. I think what we're seeing, and from our point of view, is the ever growing portfolio of use cases and the value add that we continually get. A lot of these are driven by the customers, and a lot of them are asking very, very interesting and challenging questions. I think, as Dom has said, is that we're not competing with existing technologies. We are basically utilizing this as a new technology, although it's been around a long time, but there is general acceptance. We have to continue to address the issues of certification and acceptance, and primarily by customer or by regulatory authority. That's always a challenge. But the fact is that we've got all this information, we're collecting huge amounts of data, we're meeting the requirements of the customer, we're going to places that the other technologies won't do. And what we're doing now and what we're seeing, we're being actually driven by customers rather than basically projecting a technology or a new way of doing things. So we're very, very encouraged, and it's in all industries. It's in all industries for all sorts of reasons. But fundamentally, if you really bury down to it, it's sustainment, it's the cost, and it's the time. So if you start looking at that, and that presents itself in most industries in different ways, but at the end of the day, they want product out the door, or if they've got product, they want it to be sustainable. And that's certainly what we're seeing in our Australian government defence situation, where they're basically effectively changing their focus from what I call new toys to how do we sustain these for the next 50 years, because we've invested heavily. So we're seeing this continually, and it gives us great faith and certainly great opportunity for the technology.
Fabulous. And I think you brought up a really good point there, Neil, around the certifications and the certifying bodies and kind of getting everybody moving forward with this. And I know you guys have been at the forefront of some of those activities. So it might be good just to share a little bit with the community about what you guys are doing to kind of help drive cold spray into that readily adoptable process across the globe. Because I think that's so important for hitting those kinds of targets that you're talking about out in the future.
So from where we look at, we're very, very, we focus heavily on what the customer wants and what he requires. So, but what we're also doing is to give a general data or a process spec. So at the moment, we're going through the final ballot for cold spray additive manufacture. We are the sponsor of that particular SAE standard. So that's a generic standard. We see there's a great deal of value in it. We're looking hard at how we can work with or within the SAE for additive manufacture repair, whether that is a large document covering all additive manufacturing elements, or whether it is just specifically for cold spray. But the thing here is, one of the things that I've learned, you have a great launching pad if you can say, yes, there is a standard or there is a spec out there, and the mill standard was a great start and still is. What we're looking to do is to make it more, I guess, user consumable to the greater industries rather than just a military element. And that's where we see is to basically understand who is the acceptance authority, what does he want, and we're going through significant trials, but we listen to our customer, and if the customer says, you know, have you done this corrosion trial, and we're seeing, particularly for the gas and fuel and the platforms that'll be in very, very harsh environments, new requirements for testing and those sorts of elements. So we work with them, we work with our research people to say, okay, here's effectively an acceptance strategy or a certification strategy. If we can feed it into or build upon an existing specification, that is by far the best way to approach it. But we, as I say, is that we know there's a lot of testing specifications and things like that. It's how you put them in a mix to get the customer to accept it, and that will normally be an acceptance firstly based on safety, and the second one will be sustained performance.
And you just keep teeing up great conversations, Neil, because safety is one of those things that everybody, you know, the first thing they hear is metal powder, and they say, oh no, what do I do with this? So maybe just a bit on kind of how you guys work with your customers to lead them through the process of understanding that, yes, this is titanium, yes, this is cold spray, yes, it's powder, but it's actually really safe, and here's why. Here's all the engineering that's gone into it. What are the kind of key conversations there that you have with your customers to help walk them through that journey?
Well, and I know Dom will certainly have a little bit to add to the powder requirement. So I guess again, it's basically understanding certain requirements of just general safety, general requirements, because these are airborne particles. We know some of it can be flammable and all those sorts of elements. So we do look at a whole range of existing safety requirements, particularly in countries of origin. They differ, surprisingly, or not surprisingly. And each customer has specific requirements. But it's fundamentally to look at the process, to convince him that the process is reliable and repeatable. Identify those other elements of safety and machine safety and operational safety and those sorts of things. And then basically develop good solid data on the utilisation and how the powder is being utilised. We all know it exists. And our experience with the pure titanium has given us a clear vision, if you like, of the powder and the effect of powder and how you've got to manage it and how you can manipulate it and those sorts of things. But at the end of the day, if you can't provide the data that basically convinces a customer that it meets his requirement and it is safe, then you really need to just give it away, because they will want that, and we all know why they should have it. But I think one of the challenges here is with powders. Powders are a unique element of the process. So if you can basically ensure that your feedstock is the same and you put it through some form of validation, then you'll make sure that you deliver that reliable and repeatable solution to the customer we keep talking about.
Just a quick comment on powder safety. If people look at additive manufacturing as new, and they look at cold spray as even newer, and therefore whenever you talk about powder, they go, oh, well, because the technologies are in inverted commas new, therefore there must be numerous questions around powder safety. But the reality is metal powder manufacturing techniques pre-existed metal additive manufacturing and pre-existed cold spray. Thermal sprays have been using metal powders for ages. Metal injection molding, there's tens of industrial applications for metal powders that existed way before additive manufacturing or cold spray was even on the scene. Therefore, there is a very, very robust framework for dealing with metal powders of all sorts. And as long as we, as an industry, leverage those pre-existing frameworks for dealing with metal powder, and then start to look at some of the unique issues of our process, safety is not a challenge. Work with a good vendor on your dust extraction system. Handle powder like your powder manufacturer recommends you do, like every other powder has for 50 years, and you'll be fine. It's not an unusual risk. It's not a risk that can't be addressed. It's being addressed every day by thousands of people around the world.
I think that's such a great point, and I think leads to maybe another kind of one of the key legs of the process, and unique for you guys especially, is you've spent a lot of time going through and evaluating, investigating different materials, different powders, different geometries of powders. What have you found that you think is just really relevant for the community to know about how to select and optimize your materials for the cold spray process, and maybe highlighting some of the key differences or challenges that you've found along the way that would benefit the broader community?
So maybe I'll have a sentence here, Neil, and then you can make it sound really smart. But one of the things we firmly believe in is validation of powder. So not just looking at particle size distribution and chemistry and morphology, and then saying, therefore, any provider who meets these will be okay. But we believe very, very strongly in validating powder from a manufacturer, clear powder specifications, and sticking to those. So and maybe it's a maturity of the industry, I don't know, but we do not believe that you can take a specification and swap powder vendors without thought. And it's something I know that is something we strongly believe in. So the cold spray process adds huge amounts of benefits. For instance, in titanium with powder, with our ability to manipulate oxygen-nitrogen behavior, and therefore selection, validation becomes crucial, and then sticking to the specs and the vendor that you have qualified becomes really, really important. Neil?
Can I just also add in there is that And most people will know from my background, been around this cold spray for a long time.
100
And
years.
yes, and I was always focused on spherical powders, right? So that was the basis, and I used to quote this with gay abandon about how you could basically apply the laws of physics to a spherical particle, and a lot of the work, a huge amount of work's been done on the basis of spherical powders. What we have found, because we went to the commercially pure titanium in the form that it came in, all of a sudden, irregular shaped powders have appeared, and we're finding significant benefit of those. So I think what it's doing to us is opening our mind on elements like the morphology of the powder, the shape of the powder, what do you actually want, the build structure of it, and those sorts of elements. So basically, I think our mind has been opened significantly on powder shape and how it performs, and I think that's where we go into a much broader approach when we're looking at solutions. Um, and if you look at why commercially pure powder, because of cost, primarily, and we were pleasantly surprised. So our mind is much, much more open to how powders are produced, how powders combine, how powders deposit, um, and elements of powder deposition, the criticality of porosity, and all sorts of things. So we're much more focused on material outcomes than specifically elements of powder shape and velocity profiles and a few other. But they all are very important, but they come together as a recipe. I think we've mentioned that before.
I think that's music to my ears, and I know that the ears of most in the community, because it's really important that we keep kind of learning from those new opportunities and kind of new form factors that present themselves here. Is there one material on the horizon that you guys are really excited about that you're developing that you want to kind of tease for the community here?
Tom?
I'm not sure, to be honest, if we have an official powder that we're excited about, but I personally am exceptionally excited about our work being done on Inconel 718 and 625. The Inconel series are challenging and have some, there's not everyone has succeeded doing it in additive manufacturing, and it brings some unique capabilities or challenges with regards stress management. But for me, being able to produce very large, highly dense, mechanically strong, heavy, large Inconel components will be a game changer in this casting and forging replacement area of cold spray. So for me personally, the Inconel series replacement work that we're doing on or Hastelloy or those super alloys is exceptionally exciting. And I suppose one other that I'm starting to love is tantalum. When we first looked at tantalum, it was purely from its radiation shielding capabilities, but all of a sudden tantalum, we're seeing huge amounts of opportunities in corrosion, in heat management, and spraying tantalum additively is a challenge, but our team have taken that challenge up, and we last year made our first few tantalum rocket nozzles, which weren't easy to do, but have been done, and we'll continue that development. So if I was to choose, commercially pure Ti is a Titomic staple now. We understand it. For me, the exciting metals are nickel superalloys work we're doing, and the tantalum additive manufacturing work that we're doing. Neil might have a different interest.
No, I have a very similar interest, but I think what excites me is the ability to use the cold spray technology process to look at different powder blends to solve different problems. So we now have understanding of individual materials, but we're also gaining a lot of experience on how to blend them into a situation where it meets the specific customer's requirement, rather than saying, you've got a size 10 foot, we're going to put you into a size 8 shoe, and we'll just supply pressure and Vaseline to make sure it works. I think what we're saying now is, what is your problem? What is your real problem? What do you really want out of this coating or this deposition? and let's look at the how we can mix. And I think the element there now that we have is with the concept of visualization and the ability to use very, very good predictive models and visualize, we can now answer a lot of those questions before we start doing hundreds and thousands of tests. So the digital world has enabled us to basically say, yeah, what happens if we mix this ratio? What happens if we mix these sorts of materials? And actually visualize the outcome to get a better understanding.
That's awesome. I think everybody's excited about going towards some of the even higher performing, higher capable materials. And one of the keys there to get to that point is obviously the equipment. And so you guys are kind of in a unique position as sort of the integrators of the community, that you have a lot of flexibility here in terms of what the capabilities are that you can deliver. So would you mind and there's a specific question in the chat here around the temperature for the D623 system, but I think in general, what do you guys see as kind of the framework that you work in for delivery of these integrated systems, maybe from temperature and pressure ranges to size ranges that kind of people could take home with them?
So it's a good question on the D623 temperature and pressure, and sadly, I don't know off the top of my head. But the data sheet is available, and we'll make sure that if someone just drops a note on the website or sends us an email afterwards, we'll share the data sheet. Our framework for building solutions comes down, I think, and it sounds like such a sales pitch, it's the solution. So we don't try and shoehorn people into what suits us, but definitely we look at what suits the requirement. And a great example, we had an inquiry last week from a customer up in Sydney who wants to look at repair of some steel components. So when we bring it in, the first conversation with the engineering team is, does this make sense? Do we think we can add value? I'll go, yes. Then we say, okay, what machine could it work on? And the engineering team, and I know one of them's listening, have a favored machine, but then we look at it with the lens as well. Well, what can the customer afford? What does he really want? What are we looking at long term? And we then select the machine portfolio, whether it be low, medium, high, high integrated with number of vendors, comes down to cost, deposition efficiency, freedom of movement, size of the part. So I wouldn't say that we have a favored solution. I wouldn't say that we guide people to meet what we want, but the framework is, what are you depositing? What are you trying to get out of it? What capability do you have to spend on repair and maintenance and AM? What makes sense your end market? We always talk about, this is what we would charge you for the part. This is what it would cost you if you made it yourself, if you owned your own machine. Does that fit? How do we help you make it fit? How do we do a complete ROI on the value you will be providing your end customer to make sure it makes it work? So we don't have a one-size-fits-all solution. Definitely not.
Excellent. That's what the community needs, solutions. So I think we've got one final question, and then we'll have to break for our hour here. This has been an awesome conversation, guys. I really appreciate the time, but there's a lot of interest around a combination of ceramics and metals. And so we have a couple of different questions around that area. So would you mind sharing just kind of what's on the radar for you in the materials world and in the cold spray world around that ceramic metal matrix composite that everybody's chasing after?
So all of us in any company, you find people have favored applications and machines. So I have and I don't know why, but I have this love of ballistic protection. So we are doing a lot of work around how can we work with our customers to look at creating a homogeneous single ballistic shielded component that moves from a ceramic titanium blend on the strike face to give an ultra hard strike face, all the way to a more ductile titanium at the rear to act as impact absorber. And so from the area that I'm particularly interested in, we are doing work on what ceramics can we blend with metals like titanium to create ultra hard surfaces, in my particular application as strike faces or impact faces, without shattering, but being strong enough and hard enough to actually break the tip or the velocity of the projectile coming in. I know Neil is working on a really interesting project around yttrium stabilized zirconia and rubies and all sorts of other materials for wear-resistant applications. Neil?
Yeah, I mean, what we're doing here is that we're maintaining our active role in R&D, so we're well aware of what we think is the technology advancement in materials by utilizing the ceramic blends. But obviously, we're also very, very conscious of that we don't go too far, too fast in an area where the return on investment is a long way off. So this is where we get back to the commercial realities of really listening to what our customers want, keeping a very, very focused eye on where the developments are and doing all the reading and things like that. Certainly Dom, in his role as in the sales area, is always probing our engineering and our historical knowledge to see where and what we can do. Yes, we are aware of it. Yes, we do have opportunity to play with it, but at the end of the day, it will be generally driven by our customers' requirement.
Fabulous. So there's questions are like continuing to pour in. So what we're going to do, we do have to break for time. Otherwise, I know we'll start losing people for meetings and everything else. But what we're going to do is we're going to provide all the questions back to the Titomic team so that they can answer them. We'll send out the answers and responses to the attendees here. So you guys should all have those. There will also be a link available to this webinar, so you can go back and review all of the great information that Neil and Dom presented here. And so as we kind of close out the afternoon session here, or morning session, depending on where you are in the world, I just want to reiterate our thanks, Neil, Dom, and Bruce, for being part of this community, for providing your knowledge through this webinar, this continued support of the Action team. I know there's a lot of great information that you guys have and a lot of great applications that you guys are pushing forward with. So I want to thank you guys for that. For those that are online, we'll have the link for registration to the CSAT and LSAT events here coming up this June. That's in the chat. You'll also see a follow-on email that'll have that link as well. We really look forward to seeing you all out there. You'll be able to see more of the Titomic crew, more of what they're up to, more applications, more materials. And I believe we have another webinar coming up later this month in May for our partners at VRC as well, who are also leaders in this space and working through a lot of the different repairs and additive manufacturing as well. So you can get a taste of what else is happening in other groups as well. And so we want to continue to be able to provide this resource to you all as a community. So we want to thank everybody who's on the attendee list here as well for being part of this journey with us together. And again, Dom, Neil, Bruce, thank you guys so much. This was absolutely fabulous, and I look forward to seeing you guys in June. Thank you all. Have a wonderful day and a wonderful evening.
Thanks very much, guys.
Thank you.